recording. We're live. Okay, here we go. Hi everyone, my name is Rob Canzaneri, and I would like to welcome everyone to the Data Architecture Virtual Chapter. If y'all can't hear me or y'all have any questions, feel free to type them in and I'll answer them as we go along. Today we have Steve LeRoy. He's going to give a presentation on I/O bottlenecks with SQL Server, and I'd like to welcome everyone. There's a past summit coming up here. I got a code here called VCSUM07, and basically if you use that code, I think you save $150. If you are going to attend the conference, type that code in, it'll save you a little money. So PASS has a lot of virtual chapters, and here's a listing of some. If you are interested in any of these virtual chapters and seeing webinars, you can log on to SQLpass.org and sign up and see their webinars along like you're seeing this one today. And finally, here's all the links to SQL Pass, and you can log in and see what's going on. They're always having great activities, training, webinars, a conference coming up. There's always things to find out when you log in. So I encourage everyone to log in. And without further waiting, I'm going to turn it over to Steve here, and we're going to start the presentation. Here you go, Steve. Are you there?
Yeah, I'm here.
Okay,
hello,
great.
everyone. How are you? Let me know if you have any trouble hearing me or if you have any trouble seeing the presentation. So just to give you a quick background on me, I've been at the DBA for about 25 plus years on large installations and small installations, mostly working around the Washington, D.C. area for a lot of 3 acronym government agencies, and then going more into the private sector, and finally ended up at Violin Memory. So having said that, I want to talk today a little bit about what Flash is, kind of where we've been in the past, what Flash can do for you and for SQL Server, and kind of identifying some of the things that you can do just from an I/O perspective to find out if you have a true I/O bottleneck and what you can do about it with Flash and SQL Server. So, kind of where we have been. Traditional storage devices, the server and the networking infrastructures performance has increased exponentially over the last few years, but storage has not. And a lot of that is because basically it was based on legacy technologies, hardware drives, which have certain physical limitations and performance limitations, and even some of the newer SSD architectures have some limitations as well, especially ones that are in a kind of a front-side cache kind of implementation, where there's still that interface with software RAID and tiering and things like that. So, but 50% of the workloads, of your critical apps are still run, and are I/O constrained. As DBAs, we have tried many different ways to tackle the issue. Partitioning, file placement, multiple file groups, multiple disk LUNs, adjusting your max stop, setting your max stop to 1 just so you can see short stroke or wide stripe across your disk. Keeping as much of your database and memory as possible, and from the host side, traditionally, if you have a performance issues, add more CPU, add more memory, add changing RAIDs from maybe RAID 5 to RAID 1 or RAID 10 or whatever we can try to do to improve performance. And then for the storage, it's always been add more spindles, more spindles, more spindles. And storage vendors have done tiering, where you have fast storage or slow storage, or front-side caching or adding more spindles. All these things have kind of been, unfortunately, Band-Aid solutions to a lot of the problem. And we've all suffered from having to try to resolve these issues. And so what has it led to for our environments? Complicated architectures, data centers where you have server storage and license bloat. You're adding more CPUs, you're adding more storage, you're creating this huge footprint at your data centers. And it's become, a lot of data centers are running out of space, power, non-scalable design, not resolving the underlying problem. And oftentimes, and the big hardware vendors love this, repeatable hardware buys, because you have to, at regular intervals, add, more spindles. So they love that. And of course, at the SQL level, long processes, long SQL wait times, long lock times leading to deadlocks or concurrency issues. All these things are symptoms of the same thing, and that's the underlying I/O issue. So along comes Flash, and just a quick overview of what Flash is. It's non-volatile RAM. Basically, your data is kept with any kind of power loss versus DRAM, which you have in your computer. And the basic architectures of Flash hasn't changed much, and it probably won't over the time. The density changes, but not the overall architecture. You have SLC. SLC is a single cell. Essentially, it's twice as fast, excuse me, as MLC, and half as dense. And MLC is half as fast as SLC, but twice as dense. So, most times, if you have a high-performing OLTP with a lot of writes, then an SLC might be more appropriate. But for most implementations that I've seen, MLC really is sufficient. There are also other types, eMLC and TMLC. They're basically just extensions to the MLC architecture. So with that, with Flash, and now for databases, it really becomes all about latency. Latency and bandwidth. How quickly can we deliver the data? Oftentimes, it's not just structured data like you would have in a database, but it's also, say for a SharePoint application, you might have a lot of video files or documents, and so you're talking about unstructured data as well. And it's not just about, delivering things for like OLTP type transactions, but for large amounts of data for your enterprise, big data solutions for your data warehouses. And systems, you're not even talking about cost per gigabytes anymore. You're talking about how quickly can I deliver the data, no matter how much data it is. Everybody wants everything in real time. I also wanted to touch on Microsoft's kind of recommended watermarks for I/O. And this is at the host level. So we're talking 0 to 5 milliseconds is what they consider a good performing I/O subsystem. And this is based on the SQL OS, or released to the OS, the I/O threads about every 4 milliseconds. Then add on top of that the round robin with the number of CPUs you have, and that's where they come up with the 5 milliseconds. 5 seconds to 15 milliseconds, give or take a few milliseconds, is considered slow, and 20 milliseconds plus is considered an I/O bottleneck. Again, that's at the host. So kind of visualizing what that is from the host. You can see here from a traditional hard drive storage solution, most of the latency at the storage level is actually in the seconds. So you're already behind the curve for what Microsoft likes to see. The next level down would be your SSD storage kind of solutions. This is where you have PCI cards, or say, from the other large storage SAN kind of solutions, you have front-side cache with an SSD solution in the back end. That is in the millisecond range. And then for pure flash storage, this is storage architected so that you don't have any SSDs actually. You have just memory chips. You can get in the microsecond latencies. It can be 3 to 10 times faster than SSD or hard drive. And you're already operating well below what Microsoft is expecting at the host. And what you see kind of at the server, at the host level, if 80% of your time is being spent in I/O waits, then the CPUs are just kind of dormant. They're just waiting. Whereas with Flash, it actually kind of takes that paradigm and shifts it from horizontal to vertical, and say now 5% of your time is spent in I/O wait. And that makes your CPUs a lot more efficient. Not only will your applications perform better, but now data and file access is very fast. And because your CPUs are performing better, you now can need less of them to be able to do the same workload. This becomes huge if you're moving from a use-your-cal structure, licensing structure, to a Microsoft, the new CPU structure that they're going to. Actually, the Microsoft sales folks are actually paid on getting people to move from 2008 to 2012 for the licensing. A lot of people can't afford it because of license structure. So now with being able to reduce your CPU footprint, a lot of people are now able to afford moving or upgrading to 2012 or even 2014. It also means that less memory is required because you're cycling through the memory quicker. So now you can allocate less memory to your SQL servers, which is also very important, especially in the VM world, where you're provisioning out smaller chunks of memory to a large amount of VMs. Process queues run much quicker. We've all seen processing where you see runnable, running, or suspended. Now what will end up happening is you'll end up seeing more of the process cycle through that process quicker. And it dramatically shortens your wait times, your lock times, concurrency issues. It dramatically shortens them. So are there any questions up until at this point?
Can you hear me? Hello?
Yeah, I can hear you.
Okay. No questions right now that I can see. We're good to go.
Okay, good. So moving on. So understanding what Flash can do for you and for SQL Server. The first thing you have to ask is Flash right for you? And that's kind of understanding what your I/O performance is at. And then one thing I want to touch on that I run into a lot, Flash will not fix bad code. The only thing or design. It just doesn't do that. And one of the things I'll show you in a few minutes is how you can tell the difference between, just from running some perf bonds or even some DMV queries, how you can tell the difference. And then I'm going to go over some of the things that SQL Server, what you can do with SQL Server on Flash. So detecting or improving the I/O bottleneck, excuse me. The categories for the tools that you can do pretty much fall into 4. You have your normal DMVs. They're good because DBAs know them. They can be a little hard sometimes, just capturing the, making sure you capture the time slices, and they do tend to get aged out, so you need to work around that. But if you look at the DM I/O virtual file stats, you can get about 90% of what you need. SQL Server traditionally has been not very good at capturing CPU statistics, but which the virtual file stats does not capture. But you can kind of get around that with using perf bonds. Perf bonds are good because you can, every Windows server is going to have them. And if you're really trying to just whittle down to the I/O bottleneck, it's also nice to give your storage admins something that shows not necessarily something from the SQL Server internal, but from the host itself and what the host is reporting. It's got a small footprint, And even though there's millions of counters, there's really only a few you need to look at to really determine if you have an I/O issue. And then there's also SQL reporting, the management, excuse me, the management studio reports and the resource monitors. Those can be somewhat, especially the resource monitor can be somewhat resource intensive itself, but some people still use them. And then there's also third-party tools, things like SQL Monitor or Market Arrow, SQL Sentry. All these have very good tools. The granularity sometimes is not as what you would like to see because they do aggregate a lot, but it's good for historical data, and for large implementations it can be quite expensive to do it that way. Usually what I recommend to people is just running some perf mods or some DMV queries, and that's kind of what I'm going to focus on now. So DMVs, now this is a very busy screen. I threw up a typical query from your virtual file stats. One of the things you want to make sure you do is when you're running your test to prove it, you need to take those time slices because it is cumulative data, and you want to compare the delta. I took something just from my laptop, but the things you really want to focus on for the drives is the average I/O stall here. Oops, sorry, clicked on the wrong button. Is the average I/O stalls for reads and writes. That'll tell you what per I/O you're seeing. Anything above, I would say 10 milliseconds is problematic. I'll get to that in a minute. And then also you want to look at the overall performance. And it's just a simple matter of gathering the number of reads and writes versus the stalls and then averaging them out. But it's very important that you really look at the deltas. Some people just look at the virtual file stats, and it's from the beginning of time. And it may not actually be indicative of something that might be an I/O issue. Second one is perfmod. Up here I've listed the counters that you need to look at. I have given Robert my presentation, so if you don't have to write these down right now. But these really do show you what you need to look at. You need to look at I/O sizes because SQL Server does operate at different I/O levels. It tends to write transactions from the transaction log at the sector size, so it can be either 512 or 4K. And then you can do 8K page reads and 64K page writes and reads. And then when you start getting into things like index rebuilds, where you can get up to 120K I/O sizes, and to the backups, and restores, which can run anywhere from 1 meg to 3 meg or 4 meg per I/O sizes, you need to be able to take a look at that because that's going to impact your latency. For higher I/O sizes, you would expect to see slightly higher latency but higher throughput as well. For lower I/O sizes, you would expect to see a little bit lower throughput but extremely lower latency. Look at the disk queue length, average disk queue length. That's going to tell you, what your HBAs are doing and how backed up your I/O is at the HBAs. And then you want to look at, obviously, at latency. And latency is the average disk seconds per read, transfer, and writes. That's going to be huge. Again, anything above 10 milliseconds, and you're going to start looking at an I/O bottleneck. And then your overall throughput, which will be your writes per second, disk read bytes per second, disk transfers per second, and disk write bytes per second. And then from the SQL Server side, you want to look at your cache hit ratio and your page life expectancy. Now, page life expectancy, they're not as straightforward. Page life expectancy, you're going to see higher with OLTP type transactions or systems, and it's going to be lower for data warehouse type applications, just because you're reading so much data in. Pages tend to get swapped out more regularly. The buffer cache hit ratio, that can be a little bit of a misnomer because it might have been actually read from a prior I/O or satisfied from a prior I/O. So you might see it at 100%. It will actually go down for heavy data warehouse applications, again, because pages are getting swapped in and out so much. And then you want to look at your processor times, obviously, to make sure you're not either flooding one CPU versus another, and you're spreading your I/O evenly. And then you want to look at your context switches. Context switches, Microsoft, because the CPU is thread-based, it's hard to tell your I/O weights per process. But it is a good indicator for anything. Microsoft says that 20 to 40,000 context switches per CPU is normal, and that's from any any kind of interrupt that might be happening going on with your CPUs. Anything above that per CPU, then you probably are starting to get into large I/O weights. I would recommend, when you're trying to detect if you have an I/O issue and flash is good for you, that you try to keep your window for either the DMVs or the perfmons small. That allows you to one, look at very detailed data, especially if you set the collection interval to 5 seconds, and it allows you to detect whether something is actually a sustained issue or just bursty issue. So how to kind of read your findings. Spikes happen on I/O all the time, and you're not really focusing on the spikes. You're focusing on sustained I/O profiles. Then there could be a lot of reasons for this, and a lot of times people see that a huge spike in latency in I/O, no matter what your I/O subsystem is on the background. When say you kick off a bunch of backups, and the reason for this is you're submitting a large I/O, and there's a certain amount of I/O prep that has to go on from the OS and the HBAs, and that can slow things down a bit. But then it will level out, and even for large processes like ETLs, when you kick off a bunch of ETLs at the same time, or a bunch of index rebuilds, you'll see a big spike and then everything will level off. It's not necessarily a problem. You really want to focus on sustained I/O latency and throughput. And here are some general guidelines that actually have been fairly successful in determining whether or not you have an application issue or an I/O issue where Flash can help. If your CPU utilization is 90% or less, and your context switches are more than 4,000 per CPU, and you're averaging more than 50 megabytes per second for a sustained period of time, and your latency is higher than 10 milliseconds, and Flash is going to help you quite a bit. And a lot of people have this, and that's really kind of the watermark that dictates whether or not I tell people when I go on these Flash implementations or whether or not we're going to help. If the CPU is above 90%, when you're seeing the same kind of criteria, you might be CPU bound. But again, Flash can probably help out quite a bit because it reduces the I/O weight so much. It makes your CPUs more efficient. So Flash can possibly help you out there as well. Take a look at the time. It's very important. Like I said before, because of the higher I/O profiles for some of the system maintenance things you do, like index rebuilds or backups or things like that, if it's not affecting your daily operations and not affecting your client, it really determines a matter of knowing your profile, whether or not it's impactful to your bottom line. If you're still running within whatever SLAs you might have for your particular site, then you probably are okay. It's really what's impactful. Now, sometimes the ETLs are running into your daytime hours, and that's where you really want to start looking at it. If you see that your application is doing 50 megabytes per second and bursty, like you'll see, a burst of 50 megabytes per second, and then it kind of levels out, and then maybe a couple seconds later it'll burst again. 90% of your work is being done in memory, and even if you're suffering from high latency on the back end, even putting in Flash is not going to help your implementation. because most of the work is being done in memory. We can help maybe a few things, but it's not going to change your application response time a whole lot. So that's something you need to be able to be aware of as well. At this point, are there any questions?
Oh yeah, we actually do. Okay. First one is really for me, and I'll just answer right now. The webinar will be on the SQLpath.org website under Data Architecture. I'm going to put a link to the webinar. It'll be a YouTube video, and I will also post the slides from Steve on the site, so anyone can look at them and review them at a later point. The next question was, does the performance measures apply to virtual machines?
Yes, it does. It applies to any implementation you have, whether it's bare metal or VM, and it also applies to different hypervisors. If you're running ESX or Hyper-V, it doesn't matter. They still apply.
And that's all the questions we have now. Thank you.
Okay. So, excuse me. So, moving on. SQL Server on flash stores and what it can do for you. So you have determined at this point, going through whatever your IO profile measures you want to take, that it might be able to help. And this is what you should expect from SQL Server on flash. Reduce licenses, because you have different, better CPU utilization. You can also, we have cases where people have gone from 13 4-core servers down to 2 and done the same, sometimes even more processing. This becomes really critical with VMs, and it becomes really critical if you want to move out of your user cal kind of licensing architecture to your CPU architecture, which saves people a lot of money that way. Smaller memory allocations. Before, the idea was you move as much, much of your data into memory as possible. Now, since you're actually operating at near memory speeds, you can actually reduce your memory footprint to what is usable. For data warehouse, you still kind of want to have large and kind of a large memory footprint, just because you're swapping things out very quickly. But for and if you're thinking about going to 2014, you want larger memory allocations, because SQL Server needs the usable memory for in-memory OLTP. But in general, for OLTP applications where you might even be trying to load historical data into your memory, you don't need to do that anymore. And you can still provide the speed that your clients need for response time from your applications. We've seen anything from 3 to 10x performance improvements just by plugging this in. And that's not percentage, that's X. And the difference, honestly, the difference between the 3 and the 10 is code and design. Multi-thread things now. Where before, if you were setting things, especially for database warehouse applications, or if you follow like a fast track methodology or typical data warehouse methodology, you tended to take all your data and massage it, and then set it the max stop to 1 and single thread it to all your disks. You don't need to do that anymore. You can actually reduce your ETLs by quite a bit by actually multi-threading your inserts. You do kind of have to pay attention to your page latch weights. Then you start getting into kind of table design, but you can exponentially increase the speed of your ETLs and processing. You see a reduced data center footprint. Now if you in a 3U box from a lot, or 2U depending on the vendor, and I'm being somewhat agnostic here, it doesn't depending on the vendor, you can replace 5 racks of some TMS boxes or 5 racks of your VMAX boxes. So your footprint is much smaller, but still deliver the density and the IOPS you need for your applications. Multi-tenant workloads. A lot of people try to section off their SANs so that they only do database work, or they only do SharePoint work or Exchange work. You can actually multi-tenant now, because Flash allows you to gives the same amount of performance for the IO, and it doesn't matter. Because it's so quick, you don't run into some of the concurrency issues you may have at the IO level. it's going to reduce your locks, blocks, and waits. Faster process time, faster processing through your runnable, and suspended queues is huge. Double, triple, quadruple your workloads, and still not hit any kind of CPU or memory max. Also, fragmentation doesn't matter anymore. Well, I shouldn't say it doesn't matter anymore. It still matters, obviously, to the optimizer, but from a physical level, since no heads are moving with Flash, if one page is next to each other in a read, it doesn't matter because of the architecture. So you can have pages all over the place, and you can still deliver the same amount of speed. It does not mean you don't need to rebuild your indexes or optimize for your query plans, because the optimizer is still going to cost out your query plans, based on what it thinks is the most expensive. So you still want to keep your statistics up to date and your indexes as up to date as possible. But if you're just rebuilding your indexes to get rid of logical fragmentation for speed, it's not something you need to worry about anymore. Flash is for all databases, and I'd say this, and I know this is primarily a SQL Server group, but one of the things that we've seen across the board, especially for multi-tenancy, is that you can have an Oracle database and a SQL Server database living on the same box, on the same storage device, because it's all I/O. It's just simple I/O to Flash storage. And it's good for OLTP, data warehouse, OLAP. Doesn't matter. It's good for all. Mixed workload environments. A lot of times for a lot of implementations, people have kind of a mixed data warehouse and mixed OLTP all within the same database, and that's okay too, because even though the I/O sizes and the amount of data requested for the different architectures are the same within the same database, that's fine. It's just, again, still all I/O, and it accelerates everything. If you have SLAs you're not meeting because of maintenance windows, or if you need to run maintenance more often, you can now operate within your SLAs and still give your clients the speed they need for their applications. Simplicity. I mean, one of the things that we've done about the, since you don't have to partition for speed. Now, obviously, there are reasons for partitioning outside of just speed. But if you're partitioning for speed, or if you tend to create a lot of work groups and NDS and LDS for your databases, you can now consolidate them and still get the same amount of speed. Combined data marts. I mean, this is kind of big in the data warehouse environment, especially if you're using SSAS or if you're following a particular fast track methodology. A lot of people segmented their data marts so performance from one will not affect their performance from another. Now you can kind of combine them. If you're looking at an accounts receivable and accounts payable data marts, and they share a lot of data, now you can combine those into maybe one data mart and still provide the speed that you need. And performance, industry-leading performance, enterprise speed, optimal TCO for your applications. And you can shift between dynamic and ad hoc workloads a lot. And scale, this is also important. Performance is scalable. A 3U unit, if you get 1 million IOPS, or you can get 4 gigabytes per second out of a 4U unit or 3U unit, adding another unit, that means you can now get 8 gigabytes per second at 1 million IOPS, sub-millisecond latencies. And then adding 3 and 4, it's just exponential. So building out a scale-out kind of architecture is very easy. I kind of wanted to touch on 2014 a little bit. For those of you who are thinking about moving to 2014, especially if you're planning on utilizing the in-memory OLTP. In-memory OLTP is blindingly fast for OLTP applications, but it does rely on a file stream log file, a BLT log file, to support the in-memory table processing. That has to run on Flash. Whether you do it internal PCIe cards or externally with a SAN device. It has to run on flash. The reason is with the latch list or our optimistic latch design and the row versioning, if you have a commit on a row, any transactions behind that are going to fail until that commit has been released. And so you need to process that commit as fast as possible. Microsoft is actually recommending that you write a wrapper around your current processing or stored procedures to catch failed transactions and reapply them if you're not running on flash. So it can be quite an architectural design to move to 2014, as well as all the other things like going to native compiled stored procedures and managing your memory, your usable memory within the allocated memory within SQL Server. You have to make those as well. I kind of wanted to touch on that a little bit. There are kind of three standard implementations and generations for Flash. I think most people are familiar with how Flash operates, but the first one is a PCIe card that's directly attached to your host or into your ESX appliance or your other hypervisor appliance, and it's very quick. It's the fastest out there because it's PCIe, it's internal. The problem with the PCIe cards is that they tend to be not as reliable as far as wear and tear and duration. High IOs can cause a lot of garbage collection, which can slow things down quite a bit, and they tend to fail. And there's no HA involved, so people have bought third-party applications like SIOS to help that, to mitigate that, but then you have the additional expense on top of that. So they're very good. Also, because they tend to fail a lot themselves or slow down a lot, if you put a lot of them and just put your temp DB on them, if they fail, you can still lose your uptime, because once you lose temp DB, you may not be losing any data you need to keep, but your SQL Server still goes down. The next generation is SSDs. They are very good for big iron, like NetApp or EMC, because they can plug directly into their existing cases, existing enclosures, but they're still managed by software RAID and tiering. And that tiering and software RAID can cause latency just because of the way it operates. The other thing that you need to be aware of, too, for garbage collection on SSDs, if they're commodity SSDs, then you can actually stall I/O if one of them happens to be in garbage collection. And sometimes they call garbage collection trimming or with the right cliff. It's something that all Flash has to deal with as far as cleaning up or reusing space. That operation itself takes about 3 times longer than any read or write. And all Flash has to deal with it, so how an appliance deals with it is critical. But it is safer than PCIe cards because it's usually in SAN implementation or NAS, so you have that kind of redundancy. The third generation, the kind of third implementation, is purpose-built Flash. And that is Flash that doesn't have SSDs. It's got hardware RAID, and it's got memory flash chips inside the box. It helps mitigate the garbage collection because you have more controllers to apply, and you also have garbage collections running in the background. And for most purpose-built Flash, you have one supplier, one vendor for the Flash, and that helps quite a bit as well because then the controllers can talk to each other, and it helps mitigate the garbage collection as well. You also achieve massive parallelism. Instead of IOs being striped just once to, say, a array 5 group, it's striped entirely throughout the array. So you get massive parallelism, so you speed things up that way as well. I have some other, the other thing, ask your Flash, if you're thinking about going to Flash, you need to ask your Flash vendor this. You should ask any Flash vendor. The technology ownership. So if you have commodity SSDs, let's say, you can have an SSD, pulled out a disk tray, you can have Western Digital, Seagate. You can be the same thing for Flash. You can, if you're in an SSD environment, you can have Sony, Samsung, Toshiba, any one of those. That's important for support because if you start getting down to a problem at the I/O layer and people start pointing fingers, if you have one flash vendor, there's no way to point it at somebody else. This also helps mitigate the architecture as far as the controllers being able to talk to each other. Obviously, a Samsung SSD is not going to talk to a Toshiba SSD. High availability. How many units does it take to achieve HA? Some have blindingly fast storage in 2U, but you need 2 of them to provide HA failover. Dedupe and compression. Dedupe and compression are great, and they're very good for VDI environments, but they're very bad for, they can be very bad for database environments because there's too much behind-the-scenes processing going on to dedupe and compress the data. You're actually better off being able to turn that off. And if you can't turn that off at the one layer, then you're going to create slowness just at the underlying layer. So if it's inline dedupe, you can't turn off, then it's going to be a problem in your performance. Parallelization. Can you parallelize through the full array, or do you have software array groups you have to deal with, aggregation across array groups, and having to band-aid solutions around just form factors of SSDs. And then finally, user-facing architecture. Is it easy to create a lot? Is it easy for your storage people to manage the environment? Can they do it through a single pane of glass? Or do they have to manage the units separately? Okay. At this point, do we have any questions?
Oh yeah, we have several here now. Kind of read through here. First one says, what happens to a CP? Not really sure what CP is off the top of my head.
Yeah, CP in what context?
Yeah, that's what let's see, I'm reading down the list. Thus is underutilized. I'm not sure, maybe,
CPU maybe?
Yeah, maybe so. Maybe he meant to say CPU and the U got dropped off. What happens to the CPU?
What happens if the CPU is underutilized?
Yes, that's what I think he's trying to tell me.
If the CPU is being underutilized, but you're still seeing latency on your I/O, again, it depends on the I/O profile. If your latency is above 10 milliseconds and your I/O is still just bursty, then flash probably isn't going to help. On the other hand, if you have underutilized CPU, so defining underutilized, if you have CPU at the same time as underutilized CPU that is being used at like 100%, so say you pull up Task Manager and you have one CPU to 100% and the rest of them are at 0, that probably is either a single-threaded process or a process that has gone into a hash match. Microsoft likes to, for unsorted data, will do a hash match, and internally it sets the max stop for that process to 1. So you will only use one CPU, even if you're multi-threading or if you have multiple joins in the query, it'll single-thread it. So it really depends on the process, but usually that means if you have underutilized CPU and one that's being used a lot, then you have the single-threaded process. I hope that answers the question. I'm not sure it does. But.
Well, we'll move on and see if they want another question on that subject.
Okay.
The next one I see here is this a replacement for SAN?
Yes. SAN. So the idea is to replace the SAN architecture or NAS. It doesn't matter. A lot of them, use SAN and NAS a lot for HA mostly. Otherwise, we would all do it internally. So it is to replace that side. If you want to go strictly internal to the host, then you would probably do some kind of PCIe card flash. But otherwise, you'd want to replace your SAN infrastructure.
Okay, and that kind of answers. Let's see. The next question here is I lost it. How easily can we integrate this with a SAN? So that kind of goes along with the prior question, I would think.
So at this point, you know, for most of the implementations, it's very easy. It's just a matter of adding the storage to your SAN environment. Now, a lot of SANs operate behind things like VPlex or SVC. Speaking strictly for Violin, can't speak for all the other vendors, but we actually are certified for both VPlex and SVC, and it will plug right back into here. And same with NAS. It's just another device on the infrastructure.
Okay. Here's one a little different. It just says databases on SSD are only temp DBs, and what about BPE in 2014?
So if you're talking about the buffer cache extension, is that what he's talking about for 2014?
I'm not sure. BPE, I haven't done much with, oh, they said yes. You
okay, great. All right. Perfect. So can you repeat the question again, because then I started focusing on the cache. And,
okay, sure. Well, buffer pool extension. Okay, so here we go. Databases on SSD are only the temp DB. And what about the buffer pool extension in 2014?
Okay. So keeping, you know, what I was saying before, if your temp DB is on, if only your temp DB is on SSDs, it will make your temp DB very fast. The problem you have is if your other database files and log files are not. So then now your temp DB is still waiting on the reads from a slower I/O source. So, you know, in general, we would recommend flash across the board, just so the I/O rates for your reads and writes are going to be relatively the same. But again, we're talking about changing, you know, the reliability of the SSD, internal SSDs. I mean, if it's on a SAN SSDs, then great. But internal SSDs can be somewhat problematic just because of reliability of the PCIe cards. Now, buffer cache extension you can extend to flash. And it doesn't matter if it's internal SSDs or if it's to a SAN flash. Microsoft called it buffer extension to SSDs. It's kind of a misnomer. It's really buffer extension to flash. So you can still utilize your SAN flash or your internal flash.
Okay. Let's see. What's this? For the vol and flash appliance for dispersed data centers, I wonder if he's just saying, do you support dispersed data centers?
Yes. So if you're talking about like a stretch cluster across data centers or mirroring across data centers or something along those lines, or even a multi-site cluster for Microsoft, yes, we do support that.
Okay, and he just said that's what he was asking, so great.
Perfect.
Okay, moving on. Well, we asked that question. What type of connectivity is recommended for the appliances? Fiber, 10G, 10G, InfraBand? So
it's going to depend on your vendor. I can tell you for Violin specifically, we support fiber, iSCSI, and InfiniBand. And, you know, it really depends. Fiber channel is going to be fast, you know, at least 10 gig the fiber channel, or 8 gig, you know, 8 gig HBAs are required, and multi-port. Well, one of the things about any kind of flash architecture is it loves wide. So as many paths at the fastest you can provide is best. Now, we support fiber channel, iSCSI, and we can support InfiniBand. We support all of them. So it really depends on your particular environment. And every environment's different. And then on top of that, if you also start talking about the SMB3 Direct and RDMA, which is, you know, traditional fiber channels was faster than traditional iSCSI. Once you start getting into the RDMA SMB3 Direct with RDMA, you're talking that is now faster than the traditional fiber channel. So what do I recommend? at least 8 gigabyte fiber channel and then higher.
Okay, thank you. Let's see. The last question is kind of like they're asking for a demo to better understand what type of connectivity is recommended for the appliance. Oh no, I got two questions toggled together. Bear with me. A demo would give us a good understanding of what type of connectivity is.
I do have a demo, but I think we're running out of time, and I kind of do have a hard stop quickly. But
Yeah.
actually, if you want a demo, I'd be more than willing to set one up for you privately or at another WebEx to show you the demo. We just are running out of time, and I knew we were we had to operate within an hour.
Yeah, we could have another WebEx in maybe December, or if that's okay with Steve, or we could set up a time and have one with a demo of how this works and go from there.
I'd be more than happy to. Now, the one thing about the demo, obviously, is what the demo is trying to show. So we have a generic demo that shows kind of like a mixed OLTP data warehouse workload. Will that suffice, or are you looking for something more?
Let's see if they write back. Well, we can work it out. A data warehouse demo type, they're saying.
Okay. All right. Yeah, let's talk about that, Robert.
Yeah, we could talk about that. Yeah, that'd be great. And that's,
if you want, honestly, if you want to see another demo and organize it directly through Violin, talk to your local Violin sales rep. That's my only sales pitch for the demo.
Oh, that's fine. Well, that's all the questions we have right now.
Okay.
Thank you. So I guess we could you want to wrap it up now?
Yeah, let's go ahead and wrap it up. If you have any questions about Violin specifically, don't hesitate to contact me. I believe Robert's got my contact information, or your local Violin rep. I have a couple things going into Violin, more Violin marketing, if you want to go through that. But I usually try to keep these kind of things generic, just talking about Flash in general, without going into too much vendor marketing stuff. I'll leave that up to you, Robert.
I think we're great right now. I think you've done everything, and we're coming up hard on the hour soon, and I'm gonna shut it down. Basically, if y'all have any questions, email me. I'll make sure Steve gets a copy of them. And we're going to post the webinar on our website again with the information that Steve gives me. And thank you, Steve, for coming. I mean, this is great new technology and how you can architect it into a SQL Server.
Well, thank you for having me. I know I gave a lot of information very quickly. So please don't hesitate to ask questions. And we can go into a more deep dive into any one of the particular topics you want to talk about.
Sure, and if y'all have questions, like something y'all want us to explore in a future webinar, please email me and I'll try and get it all set up. Thank you, Steve. So we're going to end it now, and everyone have a great evening. Thank y'all.
Thank you, everybody.
All right, bye.